This tutorial will show you how to build and configure a cheap temperature and pressure sensor to log data back to a central MQTT hub. This build uses a Raspberry Pi Zero W board and a BME 280 breakout board, which can be cheaply bought from eBay. Prior to configuring the sensor software, we must install Raspbian on the Pi. We change the default password and configure SSH so that we can log in remotely. Connecting a single I2C device is simple. Just use the female-to-female connections as shown. Here are all the parts on the table ready to be assembled. This is the temperature and pressure breakout board. This will be mounted outside the case away from the Raspberry Pi so that it doesn't measure the temperature of the inside of the case. This is the final wiring of the Raspberry Pi. You can see how simple it is just to wire up the 4 wires required for I2C connections. The case has been mounted on the shed wall. We have ensured that all the metal screws have been insulated to protect the Raspberry Pi from short circuits. This is what it looks like when fully installed. You can see the sensor mounted on the outside of the case. We found the IP address of the Raspberry Pi from our router, then we connected to the Raspberry Pi as the user called Pi with the password we provided earlier. First we used the Raspberry Pi config tool to change the host name of the Raspberry Pi from the default of Raspberry to something that makes more sense to you. In this example I'm doing the one for the kitchen, so it's called pysensors01. Now we're going to run apt update as the root user using the sudo command. The apt update command will fetch a new list of packages from the Raspbian repository. When the update command is completed, the package manager will have a list of all the versions of software currently on the Raspbian depot. It will know from this list which ones are currently out of date. Now we run the apt upgrade command as the root user. This will install all the newer versions of packages. This update and upgrade process should be run on a regular basis to apply fixes against known security issues. We then installed the Git software package. Git is used to version control software, and in this case we're using it just to simply fetch all the working code from the GitHub repository. We now install the I2C tools package. This package contains software that allows you to probe the I2C bus to see what I2C devices are available there. We now use the Raspberry Pi config tool to add the I2C modules to the Linux kernel. Then we will do a reboot of the Raspberry Pi to ensure the modules are loaded. We clone the Python-based software from GitHub. This just means copying the files from GitHub to the local Raspberry Pi. We modify the application config file. It is possible to have many temperature sensors in your house. Each sensor needs a unique name. Any unique name will be fine. We must also specify the IP address of your MQTT broker server. We will cover the MQTT broker in the next video. We now run the makefile provided by the Python software. This makefile will install the remaining packages required, as well as installing the application under systemd, so that every time you reboot the Raspberry Pi, the application will start automatically. We can now verify that the software is all running properly by running the command systemctl status sensors. Sensors is a new service added for this Raspberry Pi software. We can also verify that the sensor is available by using the I2C detect tool as shown here. Your temperature sensor is now up and running, and every minute it is sending a message to the MQTT broker saying what temperature and pressure that it found at that moment. In the next episode, we'll cover setting up the broker to receive these messages.